dinosaurs embody the extreme in just about every possible way. Their size, power, even the long-ago time in which they lived. It's no wonder, the more we learn about them, the more they continue to captivate us.
I think that most people have an inherent fascination with animals and with the natural world. And dinosaurs are animals and the natural world on the grandest of scales.
I think it's imagining living on Earth when Earth was a completely different place, filled with fantastical beasts that really ignites the imagination.
They're like dragons or other mythological creatures, but they were real. And that's part of the appeal. They were a real thing. They are awe-inspiring. And just take T-Rex. T-Rex is a killer whale-sized animal walking around on these giant chicken legs. You can't really compare anything alive to a T-Rex.
We know when the reign of the T-Rex ended. In the calamitous dinosaur extinction event 65 million years ago, the result of a massive meteor crash in the Yucatan Peninsula. But how did its rule begin? Scientists have long sought to learn more about the early lineage of the king of the tyrant dinosaurs. Where and when can we find the roots of its family tree? Now, new discoveries, as well as new analysis of old finds, are beginning to fill in the timeline.
Almost all we know about Tyrannosaur evolution comes from the final 15 million years of the Cretaceous, leading up to the great T-Rex. There's been this huge gap, 70 million years in the fossil record prior to that, where we've had no fossil evidence of what types of Tyrannosaurs were living here, so we really had not pieced together the first 3/4 of the story of Tyrannosaur evolution here in North America.
Lindsay Zano is the head of paleontology at the North Carolina Museum of Natural History. For more than 10 years now, she's led research teams to a remote part of central Utah, following a trail of small, ancient Tyrannosaur teeth, on the hunt for something more.
Whoa, you guys, you're really helping. It's exciting to be part of the discovery. I think that's my favorite part of the scientific process. And when we're out in the field, we come across things we never expected to find that can define our research for years to come.
And that's just what happened in 2012.
All right, so this is the upper leg bone.
When they found the puzzle pieces to a new species of dinosaur. Something very different than anything they'd seen before.
The knee would have been here. This is the lower leg bone. You can see where we cut a section out to study those growth lines. It was amazing. The first part we saw sticking out of the hill was this bone, and these pieces here are different colors because we actually found each one of these individual pieces trailing down the hill, collected them all, and then the preparation team spent hundreds of hours piecing together each one of these little bits that we had collected from the side of the hill.
After the painstaking excavation, cleaning, and assembly work, the team concluded this leg belonged to a small, at most about 180-pound animal, similar to older Tyrannosaur fossils found in Asia, hinting at a continental migration to North America.
It's a very petite animal. It would have been about human size, so when this animal was standing next to you, he probably would have been able to look you right in the eyes. And the tissue between is pretty consistent.
Zano examined cross-sections of the fossilized bone to determine the specimen's age. About 7 at the time of death. Just like counting the growth rings you'd find in a tree.
Its growth seemed to be slowing, so it was actually approaching its adult body size when it died. So this actually wasn't just a young Tyrannosaur of a big species, it was actually a tiny Tyrannosaur.
7 years old when it died, perhaps. But a fossil that's now 96 million years old and begins to fill in a 70 million year gap in the fossil record of North American tyrannosaurs. Zano published her findings in February 2019.
I chose the name Moros Intrepidus just to represent that this is really the origin story of the T-Rex lineage here in North America. Moros means the harbinger of doom, and T-Rex is definitely the doom bringer, so it all made sense.
On the dinosaur timeline, small Moros lands in the mid-Cretaceous period, while the enormous T-Rex lived during the late Cretaceous. With 30 million years in between, what suggests they're closely related? An evolutionary adaptation not present in those early Asian relatives. A specialized foot.
One of the things that makes Tyrannosaurus so special is they have a very unique foot. It's very pinched and it's designed for running and also being very agile. So these were incredible hunters that were able to chase down prey. Moros is the earliest example of those special Tyrannosaur adaptations that we found in the fossil record.
So something like a T-Rex is a small, fast tyrant dinosaur grown huge, not a big, fat tyrant dinosaur that then was evolving a few new traits to make it go a little faster.
Professor Thomas Holtz is a paleontologist at the University of Maryland, specializing in tyrannosaurs. He was part of the peer review for Zano's paper.
And with that adaptation, when they got the chance, tyrannosaurs could become the fastest moving large predators of all time. But they acquired it when they were still little guys, and they were probably using that fast running foot as much to get away from being eaten as to chase things to eat.
That's because during its time, small Moros was not the apex predator. This lush world belonged to the much larger allosaurs. Somehow, though, the allosaurs disappeared, perhaps victims of a changing environment, leaving Moros and its tyrannosaur descendants a void to fill.
And so likely as soon as their major competitors were out of the scene, they were able to seize that opportunity, increase in size really quickly, and take over as the top predators of these new ecosystems.
But what drove the Tyrannosaur's exponential growth remains a mystery. From Moros weighing in at 180 pounds, to the T-Rex known as Scotty, now considered the largest T-Rex ever discovered, tipping the scales at more than 19,500 pounds.
Why Tyrannosaurs evolved to be so big is still a huge paleontological question. Tyrannosaurus rex pushes the boundaries of any big carnivores that we know about.
Scott Persons investigates those boundaries. A research fellow at the University of Alberta, he's also lead author on a new study about the dinosaur Scotty. Fossils found in the Badlands of Saskatchewan in 1991. But its skeletal assembly was only just installed for display at the Royal Saskatchewan Museum in May 2019.
Scotty earned its name because shortly after it was discovered, the field crew got really excited, and they wanted that evening to raise a glass to Tyrannosaurus rex, to toast the Tyrant King. And the only bottle that they had on hand that seemed appropriate was a very old bottle of scotch. I became involved in researching Scotty only about 2 years ago. That was after the fossils were fully excavated and fully prepared, so they were ready for scientific study.
The team at the Royal Saskatchewan Museum used laser scanners to create 3D images of the bones. Now, almost 30 years after the initial discovery, Persons' new analysis reveals Scotty to be the largest T-Rex ever found, dethroning Sue from the Chicago Field Museum.
We say Scotty is the biggest in terms of its absolute body mass. So those skeletal measurements that indicate just how much the animal would have weighed suggest that Scotty is the most massive. And when you look at things like the girth of the femur, so the femoral circumference, when you look at the length of the lower jaw, when you look at even the thickness of the shoulder, Scotty comes out ahead.
Thomas Holtz also peer-reviewed Person's paper.
And honest to goodness, we can't say that Scotty on the lean season, when there's not much food, and Sue in the season when there's a lot of food, Sue may have been heavier sometimes of the year, and Scotty heavier some of the other times of the year. But overall, the evidence is, on average, Scotty is a larger individual than Sue, and Sue is already a really, really, really massive individual.
So Scotty is the Rex of Rexes. It's the king of the Tyrannosaurs.
An estimated 30 years old at the time of death, Scotty is also the oldest T-Rex ever found.
In a world where Scotty and the other big animals are around are only living to about, 30 years old, it's telling us there's a lot of turnover going. There's a lot of individuals changing over in the population. As I like to say, in the Mesozoic, life was cheap.
Scotty shows evidence of a busted and then infected jaw. It's got several broken and healed ribs. It's also got a number of vertebrae in the tail that show signs of very strong compression. And that may be indicative of a place where Scotty actually got bit by another Tyrannosaurus rex. So Scotty's bones tell us a lot about its very long and very violent life.
Nothing, however, is written in stone.
The chances that we've actually uncovered the very biggest of all time Tyrannosaurus rex is infinitesimally small.
So it's very unlikely that Scotty is going to remain the king of the Tyrannosaurs forever. Tyrannosaurus rex is an animal that was around for millions of years. It can be found from across Western North America. I find it impossible to believe that in all that time and space, we have been lucky enough to discover the single largest individual that ever was. There are undoubtedly bigger Tyrannosaur skeletons out there waiting to be found.
And maybe smaller ones too. Descendants of Moros and Intrepidus that can continue to fill in gaps in our knowledge.
So we need to find more tyrannosaurs that lived slightly after Moros to really understand how quickly they were able to grow and assume those top predator roles here in North America.
In the span of a month, the world learned new information about two fantastic creatures that roamed the Earth tens of millions of years ago. What's next on the horizon? How will the future shape the past?
More species of dinosaurs are being found now than at basically any other point in human history. And so we right now are in the golden age of dinosaur discoveries.
There are 50 to 70 new dinosaur species named every single year. It's incredible the pace of research, and also we're at a stage where we're able to apply new techniques to the study of dinosaurs that allow us to get new information from bones that we've had in museum collections for a very long time.
We're filling in gaps in the history of well-known dinosaurs, and we're finding specimens of even the most famous dinosaur that are telling us new things about their biology, about their growth, about their size that we didn't know before. We are nowhere near at the end of learning about dinosaurs, and in generations to come, we will be knowing things about the lives of these ancient creatures that would probably blow our minds today.